You're welcome, G. All right. Again, I haven't done a PowerPoint in probably 6 years, 7 years. I hated them. All right, so I called it 10, I don't know why, modeling with differential equations. Okay, it's partly in your book, so let's see if we can do this. I'm excited. I can't read this. So, mathematical models often take the form of a differential equation. Remember what differential equations are? Anything that has a derivative in it. Anything with derivative is a differential equation. This is not surprising because in real-world problems, we often know changes occur and we want to predict it. So we know rates a lot of times, but we want to find the original equation. That'll be the main part of today. This is a common model for growth of a population because it's based on the assumption the population grows at a rate proportional to the size of the population. Yay. So this is a very common differential equation. You got the derivative, now you don't know what k is, that'll be your challenge to find, but p stands for the population size. The good news is really for the AP test, you don't have to get too much into that. You just have to understand in general that if you have the rate, the differential equation, and you want the original equation, you're going to have to integrate. It's just a little bit more complex than that. So in this case, notice t is time, so it's a derivative with respect to time, and p is the number of people in the population. dp dt would be the derivative of the population, or it's the rate of growth. Well, a lot of times in life, that's what you know. You actually know the rate of growth. You don't know how many people there are or how many people there will be, so you'd be able to use this formula. All right. A differential equation is an equation that contains an unknown function and one or more of its derivatives. The challenge is to find the unknown function. In fact, when you go to college, there's an entire class on this one idea. You know the name of it?
No.
Differential equation. It's usually where you don't take unless you're a math major. So no other branch will take that. Yeah. All right, so this is actually off the 2008 AP test. This is part A. So they always have an A, a B, and usually a C on differential equations. One of your 6-word problems. And the problem is if you don't look at these, this is actually super easy. But if you don't look at it and get used to doing this, the A and the B will be really challenging. So the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. So the bigger it gets, this starts slowing down. When it's a baby, it's growing faster. At time t equals 0, when the bird is first weighs, its weight is 20 grams. What are they giving us right there? Yeah, it's a starting point. Time 0 weighs 20 grams. If BT is the weight of the bird in grams at time t days after it's first weighed, notice they did not give us B. They aren't giving us the equation for its weight. They're giving us its rate. Its rate, dB dt, is 1/5 100 minus B, which kind of also tells you what's the max that bird will ever weigh. So a lot of times they'll say y is the solution. So y equals bt to be a solution to the differential equation. We aren't even going to find that. We're not even going to find that. That would mean taking the integral and actually finding what the true equation is. Part A on this particular test was, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Now notice they're not asking what it weighs. They're saying is it gaining weight faster? When they ask you if something's gaining weight faster, what are they really asking you?
Acceleration?
The velocity.
It's more the velocity idea. It's a rate. If you're gaining 3 pounds a month, that's your rate. So we want to find the rate. Super, super easy. Here we go. I'm going to just use my words for the first part of this because I want to write a whole sentence out. So dB dt would give us the rate at which the baby bird gains weight. dBt is the rate. So I'm going to try to find, here we go. I'm going to try to answer this. So I'm going to do, where am I at? Hey, look at this little red dot. dB, oh boy, dt, wow, this could be interesting. So there's the rate of the bird. Now first off, B, it's capital B. What does capital B stand for? I don't know if we found that.
the weight?
Yeah, it says if BT. Now, remember, T is just the variable. B is the weight of the bird. Now, someone look at that. Tell me what happens. Can you see what I'm circling around? What happens when the bird weighs 100 grams?
It's not. It's not increasing. Or
Right. So
decreasing.
it probably reaches its max. Put 100 in there for B. B is the weight of the bird. If you put 100 in, 100 minus 100 is 0. That, at some point, the bird stops getting bigger.
So that's a critical number.
So what we're going to do is we're going to figure out what it weighs at 40 grams. I lost my little thingy here. Here we go. Wow. I might have to have one of you come up and do this. Forgive my writing. I can't be that great with this thing. But we're going to put in 40 grams. So if you want to know what the rate is it's gaining when it's 40 grams. Wow. He does this every day, huh? Is this the way he teaches every day? Mm-hmm. Wow. This is just wow. Are you guys following along? I know this is, I don't know how hard it would be to follow along or not. You guys see what I'm doing? I put in 40 grams for B because we knew the weight. They want to know how fast it's gaining. And if you know what they're asking, these really aren't crazy hard questions. Now, you'll always have to put a units. Well, I plugged it into dBdt. I think they told us what that was, wasn't it? B is the weight of the bird in grams. T is time in days. So dBdt is grams per day. So at day 40, it's gaining 12 grams per day, which is crazy fast. Uh-oh. Where's my little red dotty thing at? There we go. So the units on this, I'm writing like a third grader. Boom! That says 12 grams per day if you can't read that chicken scribble. But that's not what it asks. We got to figure out 70 grams too. And I would normally be writing out a lot more in this, but I'm just going to plug it in because I can barely do that. So I'm going to go 1/5. I'd like to tell you this is fun, but no ding-dongs. Don't do all this great calculus and then not actually answer the question. Hey, I'm getting better. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your answer. Just like all AP tests, they put explain your answer because you couldn't write at 40 grams to call it good. I've actually explained my answer by showing it. Then hopefully you could actually answer and say, hey, we're gaining weight faster here. Which kind of makes sense, doesn't it? Mm-hmm. Just like humans, when they're babies, don't they like double in a year in their weight? I hope I don't double this year. That's usually like what part A of the test will be. You just have to get used to working with a rate. So they give you a rate equation. You have to be able to use it. A lot of times they'll ask you slope. And slope seems like this hard thing. They're giving you a rate. You plug it in. That's already one of our first topics for the day. We're 1/3 of the way through the topics. Question on that? All right, I wish I could say that was... All right, here's kind of the part 2. So there's always going to be there'll be 3 parts to your slope fields question or differential equation. One of them will be these weird slope field things. And then one will be actually finding the solution, and one is kind of like the first one I did, which is pretty easy. So here's the definition for a slope field or directional field. They'll use either word on the AP test. So unfortunately, it's almost impossible to solve most differential equations. Just because I give you a rate doesn't mean you can come up with the original equation. But we can still learn a lot about a solution through a graphical approach. So when I took calculus in college, they called it a directional field. Here they seem to call them slope fields, mainly because you're just going to be finding slope. Suppose we asked to sketch the graph of the solution of a differential equation. Remember, differential equation just has a derivative involved. That's a differential equation because they're telling us what y prime is. Y prime stands for slope. It's just not quite as pretty as the ones we've done before. This particular differential equation involves x and y. It does have an initial condition there, a starting point. All right, we're going to try this again. Those are my eyeballs. Just remember y prime. Get your slope. Nothing crazy here. Slope of the equation y. Notice we don't know the formula for the solution. That means you don't know the equation. I wish I knew the equation. I'd graph it. So how can we possibly sketch its graph? Well, let's think about what the differential equation means. The equation y prime equals x plus y tells us that the slope at any point on the graph is equal to the sum of the x and y coordinates. This is why you can't do PowerPoint. You end up reading them. All right. This is going to be hard for me. I got some sort of table here. And the way the AP test does this is they don't just give you a blank one like this. They give you something like this. This is literally off the AP test. Okay, so if you look at this particular example you have a little grid, and then you can see the dots. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of them. That means they want you to find the slope at those 11 spots. But don't tell it to them in words. They want you to show the line segments. So if y prime gives you the slope, you can find the slope at any of those points. My example for you up here, I didn't do that. We're just going to do a whole you-know-what load of them. In fact, when I first did this, as you can see in my notes, I made a table of like 20. This is going to be the challenging part for me. So I always start when I'm making a slope field. You plug in a point. Now remember, every point has an x part and a y part. So if I pick the point 0, 0, the x part 0, the y part 0. Now all I'm going to do is plug it into y prime. So in this case, for the point 0, 0, the x part 0 and the y part 0, which means y prime is 0. That means it has a slope of 0 at the point 0, 0. Now you come over here. I won't be able to do this very long because I need to put a ruler on it, and I can't do this on this little thing here, but I can do 0. I can show you a slope of 0. So the way you do it, you put a little 1/4 inch long line segment right there that's completely flat, because that's what slope 0 is. Okay? And then, be honest, the whole time you're doing this, you're going to be looking for patterns. Because if you have to do one of these, if you had to do every point on that graph, we'd spend an hour just doing that. You'll notice patterns. This one's going to be a tough one to notice it on, but I'm just going to do a few points in a row. I like to start with the x's. So I'm going to go 1, 0. I'm just going one more point. Now, you don't need me to keep writing this out. Can we all see 1 plus 0, the slope would be 1? Now, on your test day, your AP test day, nice, Budo. What math teacher doesn't believe in a ruler? So on test day, you have one of these. You have a ruler. You go to 1, 0, and you draw a slope of 1. They grade these. You don't have to be perfect, but that's how you draw a slope of 1. Because look, if that's where we're going, and you're going up 1 over 1, that would be slope. Now, you don't make it all the way that, because remember, differential equations give you instantaneous slope. You actually can't guarantee it'll be 1, but right there it's 1. I can't do this like that, okay? So that's what I'm going to do. I'm going to draw the best 1 right there. And if I have to use this the whole time, it will be painful. Well, I didn't do a very good job of showing you up there, did I? Since it was at 1, 0, not 1, 1. Here's where it's at. Come on, baby. All right, let's just do a few more. I got to let you guys take over because I literally can't do this. I mean, look, we'd be here literally till 9 o'clock if I kept doing these, and I don't really want to do that. So I'm going to the next point, 2, 0. That slope is 2. This is going to be even harder for me. So now imagine, again, imagine being here but having a slope of 2. So it's twice as steep as that one. Yeah, I think you bring your own, actually, to be honest. It's weird. They don't let me in the room. So I don't, if I go in the room, see, it looks just like 1. That's why, this is where it's going to get tougher for me.
So we need to bring a ruler to.
I'll check. Yeah, I think you do bring your own, though. I can't get a 2 in there with it. All right, so I'm going to do a whole, I'm just going to start going faster. So the next one I'm going to do would be, I'm going to go 0, 1. And then I'm going to go 0, 2. And then I'm going to go 1, 1. And please tell me your work looks better than mine. If yours looks like this, I feel bad for you. And this would be an opportune time, as you're watching me just kind of bust through some of these, to It just won't let me go. It won't let me go steep enough to do that. So this is an opportune time for you to look at the one I did for you guys. Like you see the one? Look at all those little line segments I put in there. I actually used a ruler and measured them and drew them. Those are just itty bitty little line segments. And the point is, at some point you can't do all these all day, so you're looking for a pattern. Now look at the pattern I found on the one that I gave you guys. The first one I'm giving you a hint. Just look at it. So if you would have went to 0, -1, which we were going to get to, but you can see I'm struggling with this. 0, -1, the slope is -1. So I'm going to draw a -1 slope at 0, -1. And then maybe you start realizing that any time one of them is negative, and only one bigger, so like if I come over here to like 1, -2, 1, -2, 1, -2 also has a slope of -1. And lo and behold, -1, 0 has a slope. And look at this, -2, 1 has a slope of -1. So you'll find patterns where all of a sudden you're busting through these. Am I going too fast on that? The good news is on the AP test, they literally give you between 6 and 10 points usually. They're just like, hey, draw us a slope. And I saw the grading scale. And the one for 2015, the one you're going to take on Tuesday, it had 6 or 8 points. And some of them were steep, and it said that they only graded the ones that were 0, 1, or 2 slope. Because they didn't want their graders to have to grade anything steeper than that. So they graded the 0, 1s, or 2s, whichever like 3 of them. All right. I'm going to hopefully leave that up there, because one thing they'll do every now and then is they'll give you a slope field. So imagine that you've got this massive slope field. Okay? That means they've given it to you. That means if you still aren't sure what a slope field is, these are the slope fields. All these mini little line segments. It's called the directional field because it's telling where you go. They're saying, hey, if you were here, go this way. If you're here, go this way. If you're over here, go this way. That's why they're called directional fields. The thing is you could graph that equation, even though you don't know what it is. Remember, that's not the equation, that's the derivative. You could graph the original equation if you only knew where to start at. Do we have any starting points? Don't they give us one, I think, right? Okay, I'm going to go back. So, did not show up on this, but they give us a starting point. Can I not see it? What was it, 0, 1?
Yeah.
So if they give you a starting point of 0, 1, that's all you really need, and on mine it's going to be a very small graph. Because look, if you plot the point 0, 1, I still find this awkward even to today, because if you plot 0, 1, it's right there. And then you're like, am I on that line segment, or am I just above it? I don't know. But it puts you in a track that you can follow. So watch, you just follow it along, and it goes up like that. And then actually over here, it's going to turn up like this. I didn't do enough line segments to see it over here. But you're able to get a quick graph of that just by seeing the directional fields. That's usually part B, and this is crazy. To make that little directional field is usually 3 to 4 points of your 9 on that question. It's not something that's crazy hard to do. I think it's time for you guys to do a little work. Because if you watch me do another one, his desks, although weird, are pretty nice because you're all sitting next to each other. Why don't you just work with the people next to you? Make a slope field for dy over dx equals y. So that tells you the slope is y. And as you start working, I'm going to come around and check with you. And I'll tell you something here. Look how sweet that is. If it only has y involved, the x value doesn't make a difference. So as you're plugging in points into the table, start getting patterns on this one. You should get some quick patterns. Go, 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 go. Actually, I know what I'll do. I'm going to freeze it and see what I can do.
Do you plug in the points that you want?
So Gabby asked, do you plug in the points that you want? They tell you which ones to plug in. If I was doing something like this, I would plug them all right around the origin just so we get a little kind of, and I'm going to give you enough time to do about 10 points. But get some patterns so you get a lot more than that. And I know you guys can do a better job than me since I'm using this little red pen up here. It's hot here.
Do I need to leave?
What? Did you bump your head?
I'm not gonna lie, I bumped my head a few times.
Yeah, I could tell. And I don't need you to make a massive table. The more you can figure, if you can figure it out in 1 point or 2 point and get a pattern going, I'm cool with that.
I feel like I have enough.
Now you need to have like 20 spots on your graph, JJJ. But your table only needs to be as big as it takes to get like 20 or 30 spots. Well, how else are you figuring this out?
The slope field?
That's not bad. Whatever the other kids say, man, I still think you're doing a good job. Look at you.
Thanks, boy. I don't need my peers' support.
Right? Haley didn't bring the sisters this time. They didn't want to do it. Again, understand I'm working with a horrible medium here. So I'm going to stop. And just check yours. Most of you little buggers are getting it just about as quick as I did. And hopefully you understand this is probably the only reason you will need a ruler on that day. Well, let's take one just in case. All right, so I gave up and from my beautiful table. But did you guys see when there's only one variable involved, it gets pretty quick. All of these have a slope of 0, all have a slope of 1, all have a slope of -1. And the next one would probably be 2, and then 3. Why can't I actually graph something on this one, though? Right, they didn't give you a point to start at. If they'd given me any point to start at, I could have plotted it and followed the tracks. Okay? But they didn't. We good? Now, I want to go as fast as I possibly can to get us out of here, so you just tell me if you need more or less. I think this is the last one I'm going to do with you guys on this. This was an AP one. Can you see? It's like kind of a different level than what we just did. Now look, they wrote it, the reason I chose this one is they wrote it in different notation. They're saying f of x equals 1 plus x cubed minus x. Sketch the graph of the antiderivative f. Notice I say antiderivative. Capital F stands for the antiderivative. None of you in here are going to integrate that right now because it's beyond our level right at the moment. So you're going to have to make whatever the biggest table you have to make to get that going over there. Okay, so work with your elbow partner. I will now be somewhat smart. So like the question that JJJ asked, hey, or Gabby asked, what points do we choose? Well, look at the initial condition. Can you see where that is? So you're going to want a whole bunch of little line segments in this area. So see if you can figure it out. Start by first just getting the slope field, and then we'll see if we can actually graph it. I'm going to do a bunch. Now the trick on patterns on ones like this are, I mean, look at, you're taking a square root. So you'll start seeing what you can put in for x to get nice values or not nice values. Found my first pattern. Yuck. Found my first nasty one. This is tough. I wish I was using the docking camera because when you do these, I literally can do. You can actually see me truly do this. You learn to make one accurately, and then you just slide the rule. Boom. This one's about 1/2, up 1/2. So you do get pretty quick at this. It's all about having the ruler and just sliding it up and down. I can't obviously do that over here. It's actually really hard. I kind of like this because, like, you guys learning something new. And I think I'm supposed to be too tonight here.
Wait, is it? It's getting steeper. To the
It
right.
changes.
Oh, it changed?
Changes.
Oh, wait. So we could do this on one side.
As JJ gets his calculator, this would totally be on the non-calculator part of the test. And there's a reason for that. I never showed you, but on the TI-89, it actually makes directional fields for you.
Is it really?
So if you type in square root of 1 plus x cubed minus x, it would actually shoot the directional field right there for you.
How do you do that?
I don't think I'm really going to teach you that right at the moment.
9.
I can implicitly differentiate.
Yes, you can.
I get 1 for the first equation. You said you got like 1/2 or something, like going through the.
I did, yeah.
I got 1.
Dot squared.
Well, which one?
Animate
Wait, where?
alpha,
I got one
alpha,
also when I went to x value 2.
Yeah.
But what about x value 1? I think you should try that one
I
again.
don't understand how the patterns are for like. I mean,
On this one, the patterns happen since there's only x's. So, like, if you put in 1, 0, it would be the same as 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, negative 1, 1, negative. So that's a pattern. The whole line has the same slope. That's a pattern.
but I mean, like, how do you know what pattern it will follow? You know what I mean?
I don't. I do points and I think. So I'm doing, I'm plugging in a point and I'm thinking about it. Why does that? Why was the first one 1? Well, because the only thing that mattered was the x. So anytime x is 0 will be a slope of 1. Like, this is how far I am, Gabby. Gabby's convinced me now, so I'm going to unhit my little freeze button. I've only put in literally 1, 2, 3, 4, 5 points, but I have a whole lot more than that by noticing patterns. I'm trying to do the negative one now, and well, I like the first ones. So what does undefined mean if it doesn't have a defined slope? Yeah, you're out of that graph. There's no graph there. And I'm about to get there. I'm not quite there yet. This is an interesting day. No, this is one of the few times where I actually can't keep up with your guys' pace. Does Saputo have to teach this slow because of this thing?
No, he just started from scratch.
I can. So I think I got to the one you guys were all talking about. When you plug in -2, I don't know why I did that. So we got no graph over here. And this is like playing the old school video games when you stare at the screen. Like you guys are way too young. Playing back like Atari when I was like 10, and you'd be staring at the little itty bitty TV screen doing something. Well, that's exactly what this feels like. And about the same amount of fun.
Did you not like the Atari?
You'd have like one game. My very first game was a Pong game that literally didn't have you couldn't change. So all you did was turn the two knobs and watch a Pong.
Oh, that's the first video game.
I had that.
Nice.
Back in the day, all my friends used to like me. That's the only one I got. After that, they all got cool ones. I've given up.
Same.
So, if you can get to the point now, I could do this whole thing probably in 10 minutes because you can figure out the slope as you go out. You notice the patterns where they're in strings.